Welcome to Link G4x Training Part 27. In this video, we're going to be taking a look at working with our failsafe protection strategies we have in our PC Link software. So failsafe protection strategies are going to save our engine. We have our basic strategies such as our engine rev limiter and our overboost cut. So the limiter is going to go and not allow the engine to over rev past a certain RPM point, and the overboost cut is going to be cutting off our engine if we start to get too much boost generated on a turbo application. We can take a step further and do some custom programming and set up an oil failsafe protection feature or oil temperature failsafe protection feature or even a lean protection. So I'm going to go through just some basic additional failsafe strategies that we can program within our software that definitely can save our engine if we get into unsafe operating conditions. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our failsafe strategies we have available within our PC Link software. Our failsafe strategies are going to be things that we use to cut out the engine so it doesn't get damaged. So if we're talking about a main rev limiter, that's going to be a failsafe strategy. If we're taking a look at something like our map pressure protection or boost cut, we're going to utilize that on a turbo engine so that if we start to get too much boost pressure, we can shut down the engine. We don't have to worry about damaging it. So these failsafe protection features are in place so that the engine won't get damaged. We don't over rev it. We don't run too much boost on the engine. Now we can have additional things above and beyond the basic failsafe protection strategies that we have within our programming. We can also use things like our oil pressure protection or oil temperature protection, overheating protection for oil temperature, or our lambda lean protection. So we'll find that depending on what sensors we have wired into our G4x box, we can use those for logging purposes, but we can also use them for failsafe strategies. The cost of a sensor, so cost of a oil pressure sensor, is minimal compared to the cost of rebuilding your engine. So I always recommend to have oil pressure on any engine that you're working with. Also, making sure you have something like a lambda sensor so you can implement lean protection. So the two most common failsafe strategies above and beyond our main rev limiter and our map style protection or over boost cut is going to be a oil pressure protection failsafe strategy as well as a lean protection. So I'm going to show you how to implement those here in this video to make sure that you're going to save your engine in the case of something bad happening. So in the case of oil pressure, you might break an oil pump gear, you might start to lose oil out of the engine for whatever reason that might be. Maybe your drain plug came out of the oil pan. You can cut down the engine and shut off the engine so you don't damage it. Same is going to go for lean protection. If you're in boost and your fuel pump goes bad or you start running out of fuel, whatever the case may be, you can shut down the engine. You don't have to worry about damaging it. So what we're going to do is jump from our basics page here and we're going to move right into our page labeled safety. This is where we program all of our failsafe strategies within the software. And I've created this page to give just a master layout here so we can work with any type of rev limiting function. And if we take a look down here at the bottom in our parameters list and in our time plot, we can see here that within our time plot here, taking a look at a data log, we have engine speed, we have RPM limit, map pressure, so we can see what the engine speed is versus the limiter in place. Also taking a look here at our map limit versus the actual map pressure, we can see real quickly here if we're hitting that limiter and where the map pressure is at. And then we also have down here any of the statuses of any of our limiters going on. So if all of a sudden we're making pulls and the engine starts to rev limit or it starts to break up and misfire, we can quickly determine in a data log if the misfiring or the breaking up problem is related to a limiter that's in place. So these are the statuses showing, is that limiter on or off? We can see that right in here, right in our time plot. Or is there another problem? Maybe we have a bad coil or the spark plug gap is going to be too large. So it's always, for diagnostic purposes, it's always good to be able to see everything within our time plot here, playing it back in a data log. This will be an invaluable tuning tool during your calibration process because you will run into all kinds of problems with engines misfiring, and this is going to allow you to know, is the misfire created from the link because we're tripping one of our failsafe protection tables here, or is it something external that's causing the problem? Bad fuel injector, bad coil, maybe bad spark plug wire, whatever the case may be, you're going to be able to quickly determine what is going on within our time plot. So time plot down here is something that we probably going to take a look at here in the video just to demonstrate seeing a limiter being applied so you know what to look for, we know what it looks like. And then the rest of our tables here within our window, we're going to find that we have our RPM limit, our map limit, a speed limiter, we have a general purpose rev limit 1, general purpose rev limit 2, and then a system voltage limit. So these windows right here relate to how we program and how we work with our actual tables. So this is going to be essentially the background details in order to make a table work and function properly. And then the limiter table itself is going to be how we actually implement that rev limiter. So we're going to go here and set it up and then program it within the table. So that's why I have everything displayed here very neatly on the screen. It's going to be easy to find everything under just one single page rather than having to sort through various pages or go into your sidebar here and constantly pick up different menus or screens in order to try to deal with implementing rev limiters. So what we're going to do first here is talk about our RPM limit. Within our window here, we can find that we have our RPM limit mode. Now in this situation, as we're looking at it right now, we would not have a main rev limiter applied. So the RPM limit is going to be essentially known as our main rev limiter. Any engine management system, whether it's going to be an aftermarket engine management or an OEM type engine management, so you'll have your OEM ECU, you'll find that they have some kind of a main rev limiter in place. We always have to make sure that we don't over-rev the engine. If we over-rev the engine, we can definitely go and damage cylinder head components. We could overspin the bottom. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.